Hey everyone, welcome back to Ask Becca About Space. Once again, I hope you're doing well wherever you may be. I'm doing well in Norway. We are well positioned to continue moving in a direction that is at least towards our normal. We are anticipating some announcements about opening schools for some of the older kids as well soon. So I don't know. We'll see how it goes. Things are very slowly returning back to normal. In my neighborhood, we have, salons and barbershops are open. Um, Things are as close to normal as they've been in a couple of months. But we are still working from home for the foreseeable future. And I will be working remotely at least for the next month, kind of regardless of what happens here in Oslo. Okay. So today I'm really excited because I get to answer some questions from my family in Florida. So I have my cozy Michigan sweatshirt, which might seem a little bit weird, but we have roots in Michigan. And they have a lot of questions. So I'm actually going to try to keep the answers really short this time and just kind of fire through these questions to keep the video a reasonable length. Okay, so for this, I had to bust out the iPad. It's too big of a project for the phone. All right, so the first question they have is, does a black hole suck in everything around it? Great question. Well, that depends on how close you are to the black hole, right? So black holes, we've talked a little bit about before, but they are basically what we perceive to be infinite wells of gravitational potential. And so something with that much gravity, it's really difficult to escape. Every gravitational body has what's called an escape velocity. Earth has an escape velocity. The sun has an escape velocity. Basically, what an escape velocity is how quickly you need to be moving, or how fast you need to be going in order to escape the gravitational pull of that body. Now, for black holes, they're called black holes because the escape velocity is actually faster than the speed of light. So you'd have to be moving faster than the speed of light to get away from a black hole, which is why we pretty much see nothing escaping from them, because nothing can move faster than the speed of light. However, there is a threshold around a black hole where the escape velocity suddenly becomes, or I guess smoothly becomes, slower than the speed of light. And that's called the event horizon. And it's basically a threshold around that black hole where, okay, this is actually the point at which if you're inside this, you cannot escape, but if you're outside this, you can escape. And we see that happening often. So black holes don't necessarily just pull in everything around them and feed constantly. We also see some kind of quiet black holes in the universe too that are not always actively feeding, which is a question that I don't actually know how to answer, but some of my friends are doing research on quieter black holes. But yes, there is a point at which you would not inevitably fall into a black hole. But if you're inside that point, chances are you're in for a bumpy ride inside of a black hole. Okay. All right. Second question. Does the moon really recharge my crystals? Okay. So no, the short answer is no. Physically, no. While the moon has a small but considerable kind of electrodynamic diffuse type atmosphere, the moon more or less has lost a lot of its electrodynamics, if it had any to begin with. The moon is likely a chunk of the Earth that was released after a large collision with the Earth sometime in ancient history, and never had kind of the autonomy to form a significant atmosphere. So it doesn't have essentially the facilities to have a dynamic electrodynamic atmosphere, but it does have some plasma going on. And crystals, on the other hand, have ionic structures that give them often some sort of electric charge, kind of depending on what sort of crystal that you are dealing with. However, laying them in the moon doesn't do anything physically, because the moon is too far away, and the moon is not emitting as much as it's reflecting. What is charging your crystals, I think is the intent behind what you're doing. You know what I mean? It's more of you're charging those crystals with an intention, not with a physical electric charge. So when you lay your crystals in under the full moon in order to charge them, while there is no kind of physical electric process that is significant enough to alter anything within the crystal structure itself, what you're doing is you're kind of channeling your magical intentions into that object. And so for me, like, some scientists would, I guess, discredit the idea entirely. For me, it's kind of more of an ethereal and magical process rather than it is a physical scientific process. So for me, it's more about the intentionality of the action rather than the science behind it in that case. Okay. All right. Oh, sorry guys. Next question is, when can we see the smiley face? Yeah, that wasn't real. That unfortunately, it's not that it can't happen. It's just that it's not happening right now. So what they're referring to is the smiley face is a conjunction between the crescent moon and the planet Venus and Jupiter. There's like the little eyeballs. So if like Venus, Jupiter, moon. Oh, that didn't work because I can't smile like a crescent moon. It's okay. So there is a news story claiming that during the next crescent moon, which is I think on the 16th of May, that there will be what's called a conjunction between the moon and two planets. And now we are having a lot of conjunctions this season because Venus and Jupiter and Mercury are very well placed in the sky for us to see them. It's just that particular alignment of the planets is not likely to happen. And it also, the angle at which you see the moon depends on your latitude on Earth. So I guess seeing a smiley face crescent moon is more likely towards the equator, which Florida is, close-ish, it's tropical latitudes. But that particular smiley face alignment is not likely to happen because actually Venus and Jupiter will be in different spots in the sky. So they're not actually going to be in conjunction with each other on the 16th. However, there is supposed to be a conjunction between Venus and Mercury on the 22nd of May. Okay, and Mercury is a little bit difficult to see because it's quite a bit smaller, but Venus is really, really easy to see. So this is actually a really great opportunity to see Mercury because you'll have a reference point. So if you can see the bright planet Venus in the night sky, and if you look really close to Venus on the 22nd and you see kind of another dim dot, that will be the planet Mercury. Okay, so keep on the lookout for that conjunction rather than the smiley face conjunction, which I don't think is real. Okay. All right, next question. Do people really go crazy when there's a full moon? Why? Okay, this is an excellent question, and it kind of requires a brief delve into history and what we call causation versus correlation. So historically, and even up until recent history, folks have been comparing kind of upticks in crazy behavior with full moons or moon cycles. And in fact, the word lunatic or lunacy comes from the word luna, which is the word that refers to the moon, right? So even linguistically, this tells us that this kind of correlation or causation or really correlation has been going on for a really long time in history. Now, in reality, it's more or less true that people are crazy all the time, and it's just kind of convenient to have something to blame it on. However, it's negligent to not consider the fact that the moon does have impacts on us, right? Because the moon works in cycles that we are bound to, right? Some animals on Earth their whole rhythm is based on on the moon. Ours is based a little bit more on the sun, but some of our rhythms are based on the moon. Some of the things that we do correlate more with monthly kind of lunar cycles than they do with like yearly annual solar cycles, right? And so if those cycles have an effect on our behavior, then one could say that the lunar cycles do have a correlation between our behavior. Now, when I say there's a difference between causation and correlation, this is something that we have to deal with in science all the time. Just because something looks like it's related doesn't mean it's actually related. You know what I mean? So when we look at data like this, the only thing that we can say for certain is that this activity is correlated with this other activity. You can't always say this activity is caused by this other activity, because there's often simply not enough data to say so. Because we can't say there are only crazy people during a full moon. You live in Florida, you know that's not true. There are crazy people every day of the year. But you can say, we've noticed that there are more crazy people during this full moon sometimes. So that might be co-related, but it's not necessarily caused by a full moon. Okay, so the real answer is no. I mean, the moon doesn't really do that, but the moon does have an effect on us. The moon governs the tides. We have a gravitational relationship with the moon. We have monthly relationships with the moon. So any of our rhythms that are monthly, that we're bound to, have to do with the moon. They're correlated with the moon. Can the moon cause me to act like a fool? No, I'm acting like a fool all by myself, and it's convenient to blame it on my lunar cycles, right? But really, there are a lot of factors that go into human behavior. So we can't blame only the moon for human behaviors or even animal behaviors. Okay? All right. Next question. Can people live on Mars or the moon? Excellent question. So we talked about how the moon kind of lost its any atmosphere it may have had. It likely didn't have one to begin with, but Mars is another story. Mars in its early formation very likely had a significant atmosphere and a significant magnetic field that it has since lost the majority of. We also have found evidence of water on Mars. There is water on Mars to this day, but most of it is frozen. Its polar glaciers will not flow unless it's like high summer in Mars, and even then it's usually far too cold on Mars for any sort of kind of flowing ice, much less flowing water. But the canyons on Mars that are bigger than the Grand Canyon, in fact, suggest the presence of prehistoric water, right? And so one of the better candidates for life having been somewhere else is Mars. One of my colleagues gave a talk earlier this week about kind of life beyond our own planet. And he mentioned that he really wouldn't be surprised if Mars were the location of, or the place where we find kind of microscopic life, perhaps buried beneath the surface, as an indication of life that may have been sustainable there at some point. It's difficult to say whether or not life is there now. All of the rovers that we have up there haven't, to my knowledge, found any living thing on Mars. But the possibility that life could have been on Mars is considerable, because it had at some point in its history, we think, all of the ingredients for life as we know it, right? So, but the question is, can people live on Mars or the moon? Not the way that we live on Earth. And the reason for that is because of the lack of atmosphere, the lack of air, right? It's really cold, or it's very extreme temperatures on these planets. Mars is quite cold. The moon is quite cold, but there's also no shelter from sun radiation, right? Because there's none of that air kind of protecting. So we couldn't breathe, we wouldn't be safe from the sun, we would be an uncomfortable temperature. So in order to set up a colony on Mars, we would have to build it ourselves and create kind of an environment that mirrors the environment that we have here on Earth. So really staying on Earth is our best bet, because Earth is perfect and perfectly sustainable in this moment for the kind of life that it hosts now. Now, it may not stay that way due to the fact that we continue to kind of mine the Earth's resources in an unsustainable manner. But were we not to do that, the Earth would be equal and sustainable for the life that it has. Okay. And the last question, how close are we to the sun? Depends on how you measure. So astrophysicists like to more or less create distance units that are convenient to the problem. So for really long distances, we have light years and parsecs and things like that. For shorter distances, we have kilometers, megameters, and things like that. But for a distance between the Earth and the sun, since it's such a standard, that distance is actually just one astronomical unit. The distance between the Earth and sun is called one astronomical unit. But in units that we understand here on Earth, like in miles, that's about 93 million miles away. So can't drive there in your lifetime, to put it that way. All right. We are at a perfect distance from the sun that is within something that we call the Goldilocks zone. So it's not too hot and it's not too cold, but it's just right for us to live at a comfortable temperature here on Earth. Okay, so we are sitting pretty in the Goldilocks zone on the Earth, away from our star, the sun, at a distance of about 93 million miles. Okay, so thank you guys for all of those questions. That was so much fun to kind of just try and blast through really quickly. I love you very much. Thanks for sending these questions. And Max, hi. I hope you're having fun with your class at school while you guys can't be together. Hi, Maddie, Dawson, Perry, Sean, and Sam. I love you guys so much and I miss you. And I'll see you as soon as we can travel again. All right, so I have a couple of questions coming up for next week, and possibly the week after that. I have Ella and Lillian coming back up again, but as per usual, if you have any questions, feel free to send them to me. All right, be well, guys. Bye.